The question asking here is question is asking from trigonometry. They have clubbed with arithmetic progression. Angles are in arithmetic progression. Now we'll first see how to calculate the area of a triangle ABC. Let's see the notation here. Now area of the triangle ABC. Now if I call this vertex as C, this is the vertex C, capital C. The side opposite to the vertex is denoted by the corresponding small letter. Okay. Let me call this as B and let me call this as A. So this part let me call it as small b and this part let me call it as small a. Do you get it? Following. So always you know this capital A, capital B, capital C corresponds to, these parts will correspond to the vertex or vertices. Let me call ABC in maths. Whenever it is an attribute to a triangle, capital letters are always for vertices and small letter A, B, C are attributes to the sides. This we have seen when we discussed the grade 11 trigonometry topic also. Trigonometry applied to triangles. Now it's told in the problem that A, B, C are in AP, right? So let me call, let A is equal to, let B is equal to, let C is equal to. For easiness, we'll call like this. Let B is equal to B itself. A should be equal to B minus D, which means it should differ by some common difference. And C should also be differing by some common difference. Is it not? So, and we know that the sum of three angles of a triangle is 180 degree. That is the angle sum property of a triangle. So, A can be written as B minus D plus B plus B plus D should be equal to 180 degree. Minus D plus D cancels. 3B is equal to 180 degree. So, your angle B should be equal to how much degree? 60 degree. Angle B is equal to 60 degree. Now we know the sine rule applied to the triangle. What is the sine rule applied to this triangle? It is A divided by sine of the angle A should be equal to B divided by sine of the angle B. That is equal to C divided by sine of the angle C. That is equal to 2 times the circumradius. So here A is to B ratio is given, no? So I can say A divided by sine of the angle A, that is equal to B divided by sine of the angle B. So A divided by B can be written as sine A divided by sine of B value can be written as 60 degree here. So A divided by B is 1:√3, that is equal to sine A divided by sine 60 is √3 divided by 2. So you can obviously see 1 divided by 2 is equal to sine of A. This implies to me that the value of A is equal to how much degree? 60 degree. Is it right? A is equal to 60 degree. No, A value is equal to how much degree here? Sine A. Sine A is 30 degree. So now, if you consider applying the angle sum property of a triangle, A plus B plus C is 180 degree, A value is 30 degree, B value is 60 degree plus C, that is equal to 180 degree. This implies to me that the angle C should be equal to 90 degree. Angle C should be equal to 90 degree. Which means this triangle, what I am talking of here, this angle C turns out to be 90 degree. So the area of the triangle will be equal to half into base into height. Yes or no? Half into base into height. Now I just want to know what is this ratio. Half into base into height. We know A is to B. Now we can see this angle C is equal to 90 degree. And C is given in the problem as how much centimeter here? C is given in the problem as 4 centimeter. So I'll apply the same concept now. So we'll say A divided by, for this part, A divided by sine of A. Sine of A is sine of 30 degree. That is equal to B divided by sine of how much degree? 60 degree. Sine B is 60 degree. That is equal to C. C is 4 divided by sine of 90 degree. Is it right? So A divided by sine 30 is 1/2. That is equal to B divided by √3 divided by 2. That is equal to 4 divided by 1. This implies 2 times A, that is equal to 4. This implies to me that the value of A is equal to 2. And 2B divided by √3 is equal to 4. So B is equal to, what is the answer? 2√3. Now substitute here. Half into A into B. Half into, what is the value of A is equal to 2 into, what is it? 2√3. So the answer to the question will be 2√3 centimeter square, or square centimeter will be the answer to the question.